The examples in this video go with Lesson 11.2, Arithmetic Sequences and Series. Example 1. Determine whether the sequence is arithmetic. If so, identify the common difference. Part A, positive 12, positive 5, negative 2, negative 9, negative 16. All right, our common difference can be found by subtracting any two consecutive terms. So we can find it by subtracting a2 minus a1. We can find it by subtracting a3 minus a2. We can find it by subtracting a100 minus a99. However, just make sure that they're consecutive with one another. Okay. And what we want to do is we want to test this on every pair that we have showing to make sure that we get the same common difference every time. So 5 minus 12 will give us negative 7. Negative 2 minus 5 will also give us negative 7. Negative 9 minus negative 2 will also give us negative 7. And we got one more to check. Negative 16 minus negative 9 will give us negative 7. So this one looks like, yes, it is arithmetic. And we can see that D is going to be equal to negative 7 because we would be adding negative 7 every time we get to the next term. All right, part B, 1, 4, 9, 16, and 25. 4 minus 1 is 3. 9 minus 4 is 5. And we don't even need to go any further because if it's arithmetic, all of these differences have to be the same as they were in part A. So this one is not arithmetic. Example 2, write the first 4 terms of an arithmetic sequence with first term 8 and common difference negative 3, and then write a recursive formula to define the sequence. All right, if we define our sequence as A, then the first term in A is going to be 8. The second term in A is going to be 8 plus negative 3. This will give us 5. The third term in A is going to be 5 plus negative 3. That's going to give us 2. And the fourth term in A is going to give us 2 plus negative 3. That's going to give us negative 1. So the first 4 terms in our sequence are 8, 5, 2, and negative 1. Now to find the recursive formula, each term can be found by taking the previous term and adding negative 3, or subtracting 3 if you want to write it that way. And we could have written this as a sub n plus 1, and then the term that comes before a sub n plus 1 is a sub n, and we would still be adding that negative 3 there, our common difference. So either one of these is okay. Example 3, a homeowner has kept records of the average monthly electric bill for 4 years. These results are in the table. Part A, do the average monthly electric bills follow an arithmetic progression? Well, let's see. With help of the calculator, when we subtract 108 minus 102.6, we do get 5.4. And when we subtract 113.4 from 108, we get 5.4. And when we subtract 118.8 minus 113.4, we get 5.4. So because all these common differences are the same, we can say yes, it does follow an arithmetic progression. Now, part B, write an expression for the nth term of the sequence. It looks like my nth term is going to be the term right before it, or the month right before it. There should be a minus there, not a plus. And then plus 5.4. Part C, predict the average monthly bill for year 6 if this trend continues. So here we have number 4. So the 5th term in the sequence can be defined to be the 4th term in the sequence plus 5.4. In this case, that'll be 118.8 plus 5.4, and that's going to give us 124.20. And then the 6th term, this is the one we were looking at, can be defined to be the 5th term plus 5.4. In this case, we're looking at 124.20 plus 5.4, and this will give me 129.6, and there is our 6th term, $129.60. Example 4, find the 10th term of an arithmetic sequence in which A1 is equal to 12 and A3 is equal to 128. Okay, first problem we have here is that we don't actually have the common difference, so that's going to make it difficult to find the 10th term. But we can use our formula, A sub n is equal to A1 plus n minus 1 times D, and we should be able to figure out what that common difference is, because I know the A sub 1, and I'll put A sub 30n over here for my A sub n. All right, that means we're going to have 128 equal to 12 plus, now n is equal to 30, because 128 is the 30th term in our sequence here. All right, minus 1, of course, that was right here in the formula, but that's because 12 is the first term in our sequence. And of course, D is what we're looking for. This gives us 128 equal to 12 plus 29D. Let's subtract the 12 to the other side. I have 116 equal to 29D, and then when we divide by 29, we find out that D is actually equal to 4. So our common difference is 4. Now we can actually use this formula one more time if we know that n is equal to 10, because we're looking for the 10th term. So our 10th term will be equal to our first term plus the 10th term, right, from right here, minus the first term right there, times our common difference we just found to be 4. And we can put that all in the calculator at one time. And it gives me 48. So the 10th term for our sequence is going to be 48. Example 5, find the number of terms of the finite arithmetic sequence positive 16, positive 11, positive 6, positive 1, and so on, negative 239. In other words, this term right here is A sub what? We know this one is A sub 1, this one is A sub 2, this one is A sub 3, this one is A sub 4. We want to know this one is A sub what? Which number in the sequence is that? Okay, I'm actually going to use my formula. A sub n is equal to A1 plus n minus 1 times D. This is the one we're going to be looking for. I know this, I know this. I don't have this, but I can get it because I have 4 terms of the sequence right here. So let's see, 11 minus 16, that gives me negative 5. 6 minus 11, that gives me negative 5. And then 1 minus 6 gives me negative 5. So it looks like our common difference D is going to be negative 5. All right, let's plug in the parts we know. A sub n, we're going to use the negative 239 for that. It's going to be equal to the first term in my sequence, 16, plus, I don't know n, that's what I'm looking for, minus 1, because we use the first term in our sequence, times the common difference, negative 5. So negative 239 is going to be equal to 16. Now we're going to distribute that negative 5 in the parentheses. So we got minus 5n plus 5. And let's add our like terms here. We have negative 239 equal to negative 5n plus 21. And now I'll subtract the 21 over here to the other side. And we have negative 260 equal to negative 5n. And we can solve for n dividing by negative 5. And n is going to be equal to, looks like 52. So negative 239 is the 52nd term in the sequence. Example 6. For an arithmetic sequence, a sub 11 is equal to 65 and a sub 25 is equal to 149. Find the 400th term. Okay, once again, I'm going to be using my formula. A sub n is equal to a1 plus n minus 1 times d. Now, we have a slight problem here because I don't know a1. They didn't give me the first term. They gave me the 11th term and they gave me the 25th term. So I'm actually going to alter this formula just slightly. Instead of a1, I'm going to use a11 here. And if I change that one, then I want to be sure and change this one back here to n minus 11, because this number tells me which term I'm using right here in the beginning of my formula. I'm going to use a25 as my an. So what I'm trying to do is figure out my common difference, because I need that to get to the 400th term. All right. So 149 is going to be equal to 65 plus, now 149, this is the 25th term, so we have 25 minus 11 times that common difference d, that's what we're looking for. 145 is going to, 49, sorry, is going to be equal to 65 plus, and this is going to be 14 times d. Let's subtract the 65 to the other side. We get 84 here equal to 14d. And then when we divide by 14, looks like d will be equal to 6. And again, I'm going to use this formula right here. For n, I'm going to use 400. I'm still going to use a11 here. I have my common difference. an is what I'm going to be looking for, the 400th term. So a sub 400, I'm looking for the 400th term. a11 was 65. The term I'm looking for is 400. The term I'm beginning with here is 11, and our common difference is 6. And when we put this in the calculator, which we can do all at one time, gives us 2,399. So the 400th term in my sequence is going to be 2,399. Example 7, find the sum of the first 50 terms of the sequence, positive 1, positive 3, positive 5, positive 7, positive 9. We know that a1 is equal to 1, a2 will be 3, a3 will be 5, and so on. Looks like our common difference is going to be 2, and this comes from when we subtract each set of consecutive terms. Now, we want to find the sum. All right, so the sum of any number of terms in our sequence is going to be equal to n divided by 2 times a1 plus an. Things I know. I know what n is because I have 50 terms to deal with. A1 given to me, right here it is, it's going to be 1. But what I don't have is an, and they're telling me to find Sn. So the first thing I want to do is figure out what number is it that's in the 50th position of the sequence. And for that, I'm going to have to use this formula right here, the one that we've been using, to get to the 50th term. 50th term is going to be equal to the first term plus 50 minus 1 times the common difference we said was 2. We put all this in the calculator and we get 99. So the 50th term is going to be 99. Now I can find the sum. The sum of the first 50 terms is going to be 50 divided by 2 times the first term plus the 50th term. And that's going to give me 2,500. So if I added the first 50 of these terms, if I had them right here together to add, I would get the answer 2,500. Example 8, find the sum from 1 to 80 of the quantity 4i plus 3. Well, believe it or not, I am actually going to use my formula here. Again, S of n is equal to n divided by 2 times a1 plus an. But I'm going to have to use my formula 4i plus 3 to tell me what a1 is and to tell me what an is. Now a1 is going to be 4 times 1 plus 3, because I'm starting at 1 here. So the first term in my sequence is going to be using a 1. This is going to give me 7. Now an, this is the last term of my sequence. We're going all the way up to 80. So the 80th term is going to be 4 times 80 plus 3. And that's going to give me 323. Now when we find the sum, there are 80 terms altogether, so we'll have 80 divided by 2 times the first term plus the last term. And we should be able to put all this in the calculator. And it gives me 13,200. And there's our sum. Example 9, a teaching position has a starting salary of $60,000 with a raise of $3,000 every year thereafter. Part A, write an expression for the nth term of an arithmetic sequence that represents the salary as a function of the number of years of employment n. In other words, we're trying to find the formula an is equal to a1 plus n minus 1 times d, and then we're going to simplify it a little bit and turn it into a y equals mx plus b situation, just so we can clean it up. It's a little bit easier to work with. Okay, an, we don't know, that's okay. A1, they gave us, that's going to be 60,000, that's our base salary. The common difference also given to me, 3,000. We're adding 3,000 every year. And so it looks like during the nth year of employment, we will be earning 60,000 plus n minus 1 times 3,000. Now, we're going to clean that up here. And I'm actually going to distribute that 3,000 in the parentheses. This is going to give me 60,000 plus 3,000 times n minus 3,000. And then when I combine my like terms right here, we're going to have 3,000 n plus 57,000. So there's our formula for the nth term of our sequence. Part B says to find the total income for an employee who works at the job for 30 years. In other words, n is equal to 30. And it says total income. So we're not just looking for the income during the 30th year. We want to know how much this person has earned throughout the entire 30 years of their work as a teacher. So this is a sum problem. All right, the sum of those 30 years is going to be 30 divided by 2 times that first year 60,000 plus the 30th year. Oh, wait a minute, we don't know that one. So let's go plug it in right quick. Let's see. A sub 30 is going to be equal to 3,000 times 30 plus 57,000. All right, this is going to give us $147,000. All right, so there's our 30th term, $147,000. And now we can get the sum of the salaries for that particular teacher. So 30 over 2 times 60 plus 147. And that gives me a lot of money. We've got $3,105,000 that teacher has earned over the entire 30 years of their employment.